This is the Marshall DSL100H. So like just a quick inspection reveals that, so this is, these two caps here form the first filter stage or the reservoir stage for the power supply, and these two resistors go between them in a configuration that allows the voltage to balance evenly across them. But what's happened here is we've had a short from the circuit board trace. You can see the exposed copper there and all the flash arc damage, and then here's the component I pulled out. I'll replace both of them obviously, and yeah, so the body of that resistor has, the coating on it has not insulated, and the solder mask has not insulated the voltage adequately, so we've had a short there. So just looking at the design of that looks like a pretty common, looks like it could be a common fault. This is the first one of these models I've had in so far, but I would say that would be a pretty common thing that could occur. So, well, and then we've got a similar thing happening over here. This one doesn't look like it's fully flashed over. Might be, it's hard to tell from that. That might just be glue from the, but we'll do the same thing there. And probably just anywhere there's high voltage and there's a trace running under the component, we'll be wanting to lift that up. Yeah, and then on from this, just because before I sort of opened the amp up and started testing, well, finding that fault, I like to just put the valves on a tester to see if there's any shorts. So these appear to all be pretty good. A little bit mismatched, but I should be able to make a good pair, good pairs out of that for each side of the output. So probably the outer two, that'll add up to, what do you call that? You know, X number, and then these middle two will add up to X number. So they'll be, you'll get a reasonably matched pair. Just bearing in mind that one's running a little bit hotter than that one, so we'll have to set the bias, keeping that in mind. One thing to note with these testers, they're great, by the way. You know, they're expensive, but it'd be worth having it if you're doing a lot of repairs. This one tests the valves at 325 or 400 volts, and then we can adjust the different bias voltage for different kinds of valves. We've got a little chart there that makes it easy if you can't be bothered remembering all the numbers. But one thing to note with this was, I had a Fender Twin in a couple of months ago, and that one came in with a pretty obvious fault where it looked like the plate had shorted to the heater, which is a pretty standard fault in 6L6s. So it had taken out the heater balance resistors, and you know, it was pretty obvious what had happened. But I put those valves on my tester to see which one was shorted, and this didn't pick it up. It showed that they were all fine, right? And then upon putting them back in the amp, as soon as any DC voltage was applied, you'd get a really loud hum through the output transformer. I mean, like mains input of like 2 volts, and you're getting hum through the speaker of the amp. So this DSL100H is actually a milestone amp for me. I actually shocked myself off that cap there. It's drained now because I touched it with my finger and got, I measured it afterwards, and it said it had 120 volts on it. So yeah, look, it's not something you want to do. You should measure each cap at its leads, or if you can't access its leads, you can figure out how the circuit works and find like the component lead that connects directly to its positive terminal. and measure from there. And just remember, you know, if you've got a standby switch in play that isolates the filter stage from the others, you know, if it's off, you might measure there and there's nothing, because that's the balancing resistors have allowed it to drain away, but the other caps might still be fully charged. Other times you might have a failed or open component or connection repairs here. So this here will shows you why that cap still was charged. So the trace is missing there from the positive. So when it failed, that had voltage, you know, the charge, and then that shorted and went the resistor shorted to that trace, and its connection to the power supply became open on that side. This is what I settled on for repairing that trace. So I've just run a wire from the resistor over to that part of the capacitor, short and sweet. Wires wrapped around the leads, so there's some mechanical connection there. And I'm just going to inspect all the solder joints and look for cold solder joints or dry solder joints, whatever you want to call it. And just this part of the power supply has two caps with balancing resistors as well, and just starting to get the same problem there. Not as bad. There's still trace left, so all we have to do is just put some new resistors in that or clean it up, and then put some new resistors in that are mounted away from it. Throwing some new leads in. Oh, sorry, forming some new leads on these new resistors. Boom. Straight over here. There we go. It's pretty good. Pretty close for jazz. So that little kink just helps it stay above the board. Have I cleaned these holes yet? No, I haven't. Take her off, or use a desoldering gun. I don't know if you know that joke about the nails, the two carpenters working from a specific geographic location, and there's all the nails. Start again. So there's two carpenters. One of them is up on the roof, on top of the ladder, and he just keeps throwing nails onto the ground. And the other guy's like, "What are you doing, man? Why do you keep throwing all these nails away?" And he's like, "Oh, they're for the other side of the house." You know, I first heard that joke from an American person, and they said they were West Virginian carpenters, but you can apply that to anyone you want, really. Zoomers. No, I'm just kidding. Here we go. All right, putting this board back in. yeah, the cutouts for these holes are they're tight. There's no free play in them at all, so getting them in is quite tricky. Very finely engineered piece of equipment. No slop or tolerances in these cutouts or anything, so not so easy to. It's much easier to pull out than it is to put in. There we go. There's 1, 2. Just this one here. There we go. Running flush. Now we've got to put these connectors all back in the correct places. Luckily, most of them are pretty straightforward. Right, main board's back in. I'm not going to fully reassemble it until I know it's working. I just need to put 1 screw there. That's going to be a ground point. That's out of shot, but whatever. Alright, power's on. Stand by, giving it some juice. Watching for abnormal power consumption. Click in and work. Probably can't. Is that showing up? Looks like our channel switching works. That's a good sign. Effects loop's not turning on or off though. Let's give it a bit more. No, alright, let's just measure the power supply and stay on track. Now, when I like to do my measurements on a live circuit, I like to use these things, right? So you've got a very small amount of probe exposed. That way, if you slip, you're much less likely to accidentally short 2 things together. I see guys probing stuff like this all the time, and it just makes me uncomfortable. If you want a bit more safety when you live probing, you know, that works well. Otherwise, you know, keep the thing unpowered and use clips and then turn it on. It's a bit safer that way. Anyway, let's measure some voltage at the fuses. On DC volts here, can you see that? I've got 6 volts there, 60 volts, 215 volts. That's the general HDR. 157 there. 317. Nothing. Okay, so that appears pretty normal for the time being. So everything's working all the way down this end. Yes. Alright, we've got it powered up. Running for a bit. Bias looks pretty stable. It's in an awkward position, so I could get to that end, easily measure the plate voltage. Let's hear it. No, nothing's coming out. So you see these connectors a lot. Oftentimes when you disconnect them, the body of the connector will come with the other side of it, and they won't separate. They'll just lift off the pins. So when I put that back on, I thought that was the open. So often they'll have a printing there showing an open side. I just looked at it really quickly and saw thought that was the open side, which corresponds to that side, but the diagram actually shows it going the other way. So anyway, just in case you're interested, plate voltage is approximately 450 volts at 240 volts input. around 50%, but we might just jack that up just a touch. So it's not too cold if the voltage dips, the mains voltage dips down to like 220 or something. Up to halfway, we've got the volumes down at the moment. Alright, reverb is off. So just presence, resonance, bass, treble, middle, all at the halfway mark. Oh yeah, and I can't throw this away because I think it's hilarious. Power pick clamps on. Anyway, back to the job at hand. So yep, yeah, controls are new. So we've got the clean master up and the master turns up. Master 1. Use the gain control. So hang on. It jumps around all over the place. Need to service this thing. I should have set up a camera stand. Anyway. So look, so we've got probably need to increase the bias a little bit. We've got about 30 volts. So yeah, we had about 30 volts into 4 ohms, so that was 30 peak. We want that. We want the RMS version of that. So times it by 0.707. That's 21.21. 1.21. Can't type. 21 squared. It gives us 449.86. Divide that by ohms, 4 ohms in this case. It's 112 watts RMS. So she's pretty healthy. Ultra gain. Got the volume up halfway on this one. That puts out heaps more. That gives us nearly 40 volts peak there. So that's, yeah, it's healthy ads, bro. Right, there she is back in the cabinet. If you made it through to the end of this, well, thanks. I'm thinking maybe as I get time, maybe doing a series, not a series, but maybe just doing videos on like common faults of amps and stuff. Obviously, you know, all the really popular models have been done to death, but maybe this could be a useful thing for other techs. And that said too, if you have any other common things you find with these or this model, DSL100H, or I don't know, just write stuff in the comments. I'm interested to hear your thoughts either way. Thanks again for watching this bloody thing.